Welcome to the review recording that accompanies instructional recordings 1A, B, C, and D, and E for Unit 3 of Chapter 3, Mathematics 2200. This recording is based on Section 3.1, and we focus on identifying characteristics of a quadratic function in vertex form and finding a quadratic function given information about its graph. In this first example, we're asked which function has a maximum point located at -3, -5. Well, in order to be a maximum point, the graph must open down. Therefore, we can immediately eliminate option D. Next, we need to have the vertex PQ at -3, -5. Recall? If we have a quadratic function in vertex form, PQ is the vertex. Well, B would be would have vertex at 0, -5. If we think about it like this, there's been no translation horizontally of the vertex from 0, 0. And C has the P value and the Q value at 3, 5. So options B and C have the wrong vertex. Option A is the correct one. It has vertex at -3, -5, and it opens down. For this next one, we have to have a range y greater than or equal to 5. That means the 5 must be our Q value in our vertex. Well, option A has Q value 0. Option B has Q value 0 as well. Option C has Q value 5 and D has Q value 5. So far we've only narrowed things down to C and D. Option C has vertex at -1 and 5. Let's see if that has the right range. Here's -1 and 5. The graph opens down because we had a negative in front of the brackets. So this is option C. And the range would be y less than or equal to 5. So that's incorrect. Option D has vertex at 1, 5. And it has a +3 in front of the bracket, so it opens up. So it looks like this one has the correct range. Y is greater than or equal to 5. In this example, we're asked to find an equation in vertex form of the quadratic function that contains these 2 points, and the minimum value has a minimum value of -13. A quick sketch of the given information often helps. So we have a point that the parabola passes through at 0 and -10 right there. We're told it also passes through 6, -10. So let's see, this is 5 right here. So 6 and -10 would be right there. We're told the parabola has a minimum value of -13. Now, these 2 points that we were given, 0, -10 and 6, -10, they're at the same level. So our vertex must be halfway between those 2 points. Halfway between 0 and 6 is 3. So we're at 3, and the minimum value is -13. So we now have our vertex, the P value, and the Q value. And I can even roughly sketch in my parabola if so desired. So I work on finding the equation of the parabola. My P and Q values are now known. So I've got x -3 because remember I changed the sign of the P value to get to put it into the function. And then I've got plus Q, that's plus -13, which I can change to subtract 13 in a moment. Now I need another point on the parabola. I'll choose 0, -10 for x and y. So I've got negative 10, because that's my y value, equals a outside of 0 for my x, minus 3 squared, minus 13. Negative 10 equals, inside the brackets here I'll get negative 3, square root will be 9. So I really have 9a minus 13. Bring this minus 13 across and add it, or in other words, add 13 to both sides, gives me 3 equals 9a. Divide both sides by 9. I get 3/9 equals a, which means that a is 1/3, which kind of makes some sense. It's a pretty wide parabola, and it opens up. So therefore, our function is y equals 1/3 outside of x minus 3 squared minus 13. Remember that y equals a outside of x minus p squared plus q is a parabola. Vertex is p and q. If the graph opens up, then the range is y greater than or equal to q. If the graph opens down, the range is y less than or equal to q. And from our instructional recording, I've repeated the steps here for finding a quadratic function in vertex form. Determine the vertex, put those p and q values into the function, substitute another point for the x and y, then solve for a and write your function.